In this demo, we are going to cover Aarna services. As a first step, user needs to create user accounts for each of the domain, like public cloud, which is Azure, and user need to provide client ID and secrets. And second one is the VNF, which is network edge. User need to provide the details like client ID and secret. Third one is the metal domain, and user needs to provide the corresponding client ID and secret details. And the fourth one is the port, and for the port domain, user need to provide the client ID and secret details. Once these accounts are created, user can create a topology. So for that, user can click on create new, and user can give the email IDs of the users who wanted to receive notifications. Now user can select the network edge and the public cloud which he wanted to connect to. So now user is connecting the metal domain with the corresponding required details, what type of metal and what OS needs to be brought in the metal domain, and SSH user details for the metal domain, and the VLAN details for the corresponding metal domain. Once done, user can drag and drop. Now the network edge device configuration. So user can select the required configurations for the network edge, and the key important aspect is the license key for the network edge device. And user can provide the SSH details for the network edge device. And user can configure the ACL control list. Minimum to ACL sub needs to be provided by the user. And the corresponding details for the network edge, like billing cycle, term length, ASN number, all those details user need to provide. Once done, user can verify those details and can drag and drop into the AES block. Now user is configuring the public cloud, so which is Azure Express route details, and user need to provide the corresponding details for the Azure Express route, like bandwidth, billing cycle, VLAN details. Once done, user can drag and drop. So now the user can connect the metal to VNF and VNF to the public cloud. So the corresponding bandwidths for those connections can be set by the user. So once the topology is saved, user can provision the topology. So now this is what we have configured between the metal to the VNF, which is network edge, and to the public cloud. So now user has selected the provision the topology. So now once the topology provision starts, user can see the stack trace of what's happening underneath the AES. The stack trace gives user the details of what step is currently the AES is performing. If you see here, the Azure Express route was completed. Now the network edge is happening, and once the network edge is completed, the metal and the fabric connection, so user can clearly see all the details of steps which are happening beneath the screen. So once the provision is successful, the provisioning state which is displayed at the top of the screen will turn to success state. So we are waiting for the provisioning to complete and turn into the success state. As you can see, now the L3 configuration has started. as you can see, the entry configuration is done and the circuit discovery also completed. Now you can see the provisioning status has turned to success state. With the deployment, the topology is successful. So now the deployment verification steps will be performed on the topology which AES has deployed successfully. So that we can verify it using the Azure Express route, and also the corresponding success provisioning details should be emailed to the users over the email. So in the email, you will see the emails regarding the successful deployment for the network edge, Equinix fabric. So the same thing can be verified in the Azure Express route side also. So now the same thing can be discovered using the ANA database, which is being used by the AES. These are the details which has been used during the provisioning of the topology. So now user can download the SSH keys for each of the domain and log into the each of the domain like Metal or VNF, which is network edge. So now we are going to perform a diagnostic test to verify the ping between the Metal to the Azure. So if the ping is successful between the Metal and Azure, then the end-to-end topology is successful and the connectivity from Metal to Azure is successful. So as you can see, the static route is successfully configured between the Metal and the VNF. So now we logged into the VNF and trying to verify the network interfaces inside the VNF. We are listing all the interfaces and checking whether all of the interfaces are up and running. And the connectivity between the interface from the VNF to the Metal interface and the interface between the VNF and the public cloud. This is the interface between the network edge VNF and the Azure. We are verifying all those details here. This is the BGP details between the VNF and Azure. So now we logged into the Metal and we will check all the interface details on the Metal side also. As you can see, we have configured the bond 0. Now we are verifying those details in the output. So these are the bond 0 interface details. Okay, now we are doing the Metal ping diagnostic test. So this is from the Metal to the Azure. So this successful ping test shows that the configuration between the Metal to the Azure public cloud through the network edge, which is VNF, is established successfully. Now we are going to do the ping diagnostic test from the VNF to the Azure. So successful ping test here shows that the interface between the VNF to the Azure is successful. And as you can see, there are no packets drop, so it is 100% success. Now we are from the metal side, we are doing the ping test to the DNS server, which is 8.8.8.8, to see whether the internet connectivity is available. The similar test is being performed on the VNF device also. RKE cluster deployment on the metal to see whether the Kubernetes